Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is compare and connect. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. There is a multiset S containing n plus m strings, n of which are this less than sign and m of them are this greater than sign. Now these two of the strings, we can call it S and T. We define them with a function of S and T and it is defined as follows. If the string S is smaller than T in lexicographical order, then the return or the value of our function S and T is nothing but S, and we append this less sign and we combine or concatenate all these three: S, the less sign, and then T. If S is equal to T, you can guess it, it will be S concatenated with equal and T. And in case that S is larger than T, it will be concatenated with S greater than T. We need to perform such n plus m minus 1 operation, and each time we will choose two strings S and T from this multiset S, and we will insert the function of S and T to our multiset and erase the original S and T that we choose. Finally, at the end, only one string will remain, and that has to be the lexicographically smallest. That is our task, to find the lexicographically smallest possible final string after all this operation and reducing our multiset to a single string. Now let's see what is the lexicographical order that we are going to follow. Now these strings are going to be compared to their characters from left to right. Similar how we do this in an ordered dictionary. But the comparison rule will follow as following. The first character of each string is going to be compared. The string with the smallest character based on the ASCII value that we have here will be considered smaller. Next up, if the first character are same, then we are going to compare the second character, so on until we reach or find a different one. At the end, if one of the string is a prefix, then the other, the shorter one is going to be considered smaller. So, if we have something like this, comparing the greater sign with a lots of smaller sign, since the first character that we are comparing, in this case this is greater, we'll say that this is lexicographically greater than this. I hope you get the point. Let's see the input format. We have t test cases, and for each test case we'll have a single line that will contain two space separated integers n and m. As for the output, we will have to output the lexicographically smallest possible final string. For the constraints, number of test cases will go from 1 to 10 raised to 4, and the value of n and m will go from 0 to 2 into 10 raised to 5. But remember that sum of n plus m will always be greater than or equal to 2. Let's see some sample inputs. So for the first sample input, the count of less than strings is 0 and the count of greater than strings is 2. So in our multi-set, we only have these two strings, two greater sign. Now if we compare them, they both are equal. Since they are equal, we concatenate them. They become something like this, and we remove the original one. So in our set, now this is a single string left, and since this is the only one that we can form, this is by default the lexicographically smallest one. We can try the others. Let's see how we can approach the solution. Let's start with this. What would happen if there are no greater than sign? That means our m is equal to 0. It means no greater sign. This would mean that after our multiset, we will only have these less than characters. So now what would happen? If I compare two less than characters, what would happen? They are equal. So two of them would be removed and we'll have this string. Next up, what we can do? Again, we'll compare this with the smaller one. Now since we want to form the lexicographically smaller one, and as we can see from the ASCII, the smaller than symbol has the ASCII value of 60, equal to is 61, and greater than is 62, the largest. So we would want this smaller than or less than sign to be as left as possible. So next up, we'll compare this less than sign to be compared with this string, less than, equal to, and less than. With this, we can see the third condition That is, if one of the strings is prefix, the smaller sign is prefix of the larger one. Therefore, we would say that the shorter string is going to be considered smaller. So the sign that we are going to concatenate with is going to be the smaller one. So with this, for each of the less than sign that we have, we are going to append two of them. So if our m is equal to 0, what we are going to do, we will first compare two smaller ones. So we'll have this, right? And for every other smaller one, we are going to compare it with this. So it will form something like this. But since we have already used two of the signs here, this will be nothing but n minus 2 times. Now let's see the opposite case. What would happen if there is no less than sign, right? Now in this case, what would happen is the set would only include the greater than sign. Again, we'll do the same thing. Let's pick two greater than sign, and what would happen? We'll say that they are actually equal. Now again, since we have used this, we are now going to compare it with another greater than sign. Again, the third rule would apply. Since this is a prefix, we'll say that this is one of the smaller ones. So now again, what do we have here? We have this, and we have for each of the rest of the greater ones something like this. We'll print this m minus 2 times, and at the end we'll print this greater than is equal to greater than. Now finally comes the last case, that is neither m is equal to 0, neither n is equal to 0. With this, what we can do? We have the smaller signs and we also have the greater signs. So with this, let's assume we compare the less than and greater than sign. We have less than and greater than. What would happen? This one is smaller, so we'll have one more smaller than sign here. Now what we can do is for all the n, that is for all smaller signs, we can compare it with this string. What would happen? Since this is smaller, we'll have these, right? Since we have this, we can print it how many times? We can have it n times, right? In between, we'll have one of these. But what about the greater than sign? Now, if I have a greater than sign, what I can do is I can compare it with something like this. If I compare it with this, we'll see that this one is actually smaller. So what we'll have is we'll keep on having this one m minus n times. So with this, for all the three cases, we have formed the lexicographically smaller string, and with this, we'll get our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve, and in solve we take the input of n and m, and then we go over all the three cases. If m is 0, we only have the smaller sign. If n is 0, we only have the greater sign, and if both of them are not 0, we use the three cases that we saw in our approach, we print all of them, and as you can see, I've got an AC in my C++ implementation. Let's see how we can do this in Python. Again, for each test case, we call the function solve, take the input of n and m. For m equal to 0, that would mean that there is no greater than sign. So we print n minus 2 times the less than sign, and at the end less than equal to less than. Similarly, when n is equal to 0, it would mean that there is only greater than sign, and at the end, when both of them are not 0, we print a combination as we have seen in our approach. At the end, we can see that we are able to find the lexicographically smaller string, and with this we have got an AC in both the C++ and Python implementation. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.